All right, so in 4.2, we're going to start talking about concavity. And you may have heard the terms concave and convex. But in math, we're going to use just concave up and concave down. And the reason that we're going to do that is because if I say that this is concave, or if this is concave, you're really not sure what I'm talking about. But if I say that this is concave up, and the way you think about it is that if it rains, look at my little raindrops. Okay, if it rains, it'll hold water. Okay, if it rains, it'll hold water. So it's concave up that way. This is concave down because if it rains, the water will run off. Okay, so concave up will look like this, and concave down will look like this. Now, how do we do this, and what am I actually talking about? So let me give you an example. If I give you the graph and the function f of x equals x to the third. Okay, so in the last section, we talked about increasing and decreasing. So let's take a first derivative, and that gives me 3x squared equals 0. Okay, well, in that case, x must be 0 because the only thing 3 times 0 will be 0. Okay, so if I use my little tricks here, okay, so I'm going to do negative 10. So negative 10 squared is positive times 3 is positive. If I use positive 10, 10 squared is positive times 3 is positive. So we find it's increasing on the entire interval. It's increasing for all real numbers. Well, when I look at the graph of it, it kind of sort of does this. Okay, rough sketch. All right, so what we're going to do now for concavity, if you look, this is concave down. Okay, this is concave up. And then how do I find it? I take a second derivative. So you'll notice something weird was going on here because I did everything right, but I didn't have a change in direction. But if I take a second derivative, so my first derivative was going to be a 3x squared. My second derivative is simply going to be 6x. And now I do the exact same process I did before. Set that equal to 0 and now solve. So x must be 0. So now I'm going to test for concavity. So I'm going to go back to my second derivative and I'm going to test for concavity. So give me a point to the left, that's negative 5. So 6 times a negative is going to be negative. And instead of using an arrow like this, I'm just going to use a little stumpy arrow. And that's just a visual reminder for me that I'm talking about concavity instead of increasing, decreasing. Okay, so I use diagonal arrows for increasing, decreasing. I use straight up and down arrows for concavity. So if I give a number over here, let's say positive 5, 6 times positive 5 is positive, so he is concave up. So where he changes concavity is called your point of inflection. So your point of inflection, that says inflection, your point of inflection is going to be where he changes concavity. So what is our strategy? If we're talking about increasing or decreasing, it's a first derivative, set it equal to 0. If we're talking about concavity, concave up, concave down, or points of inflection, it's a second derivative, set it equal to 0. Okay, so since that's kind of sort of a, it's not very difficult to do that, I'm just going to go ahead and start going into the practice and go from there. So I want to know when I have concavity. So let's do a picture. All right, so if I have this graph, I've got vertical asymptotes here and here, and this graph looks like this and like that, and then he comes up and he does that. Okay, so I want to discuss the concavity of the graph. Well, on this side, up until I hit this asymptote, and let's just pretend it's at negative 4. Okay, so here's a negative 4 and here's a positive 4. This thing is concave up. It looks like a bowl. Okay, it looks like a bowl. And so if it's concave up, now it keeps going this way, so it only looks like half of a bowl. But it's still concave up, okay? And then this side is also concave up, but this is concave down. Now, do you have an actual place where it changes concavity? No, because there's no point at -4 and there's no point at +4. So you do have concavity going from -infinity to -4. It's concave up. And then again, from +4 to +infinity, it's concave up. It's concave down from -4 to +4. But since there's not an actual place where it changes, like it did here, this is concave down, this is concave up. Where did it change? It changed at 0 because you've got a point there. Okay, down here, I don't have a point where it changes concavity, so there are no points of inflection. There are no points of inflection. All right, so we are going to find some examples. All right, here we go. So what is our strategy? Our strategy is, if we're talking about concavity, to take a second derivative, set it equal to 0, and establish our test points. Okay, so if my function is g of x is -x squared plus 4x plus 3. So first derivative tells me increasing, decreasing, critical numbers, constant. I don't care about that today. I care about my second derivative, which is -2. Well, I cannot set -2 equal to 0, which means this is negative. It will never not be negative. So you have concave down for all real numbers. So it is concave down for all real numbers. So from -infinity to +infinity, we'll come back up here. This is a parabola that's upside down because it starts off negative, so he looks like this. So he's concave down. Okay? So we actually, being lazy math people, did not have to do all this stuff if we had recognized he's an upside down parabola. All right, so we have another one. F of x equals -x squared plus 9x plus 8. And I want to know the concavity of the function, which means I need to take two derivatives. So my first derivative is a -2x plus 9. That tells you increasing, decreasing, constant, and critical numbers. My second derivative is, ooh, look at that again. It's -2 again. So when is it concave up? Never. When is it concave down? It is concave down for its entire life because I cannot change the sign. Okay, concave down for its entire life. So let's do another one. We have g of x equals 2x to the third minus 4x. And my instructions are to determine the concavity of the function. So if I want to determine the concavity of the function, I need to take two derivatives. So my first derivative is 6x squared minus 4. My second derivative is going to be 12x. Well, now I can set that equal to 0. If I set 12x equal to 0, okay, so just refresher. First derivative is increasing, decreasing, constant, and it is critical numbers. Second derivative is concavity. So let's take your second derivative, set it equal to 0. So I've got a number at 0 that's a possible point of inflection. I'll know if it's a point of inflection if there's a change in concavity. If it goes from concave up to concave down, then there's a point of inflection here. If it goes from concave down to concave up, there's a point of inflection here. Okay, so put your test numbers in here. So if I grab a negative, a positive times a negative is negative. Okay, if I grab a number here, which will be positive, a positive times a positive is positive. So you know he is concave down from negative infinity to 0, and he's concave up from 0 to infinity. And you know he's got a point of inflection at 0. He has a point of inflection at 0. Okay, so let's try again. I have 3x to the 4th minus 18x to the 3rd plus x minus 9. Okay, I'm asked to determine the concavity of the function. So I need to take two derivatives. So 4 times 3 is 12x to the 3rd minus 18 times 3 is going to be 54. X squared plus 1. Okay. And then what do I have? I need to take a second derivative because this tells me increasing, decreasing, constant, and critical numbers. I need to know my second derivative. So 3 times 12 is 36. X squared. 54 will turn into a 108x. Set that equal to 0. I know that both of these are divisible by 36. Both of these are divisible by 36. So I'm going to divide across by 36. And that gives me an x squared minus 3x is 0. So now I'm going to factor. So I have two places where x will be 0. One of them is at 0 and one of them is at 3. So I have 3 test intervals. 3 test intervals. So I am going to evaluate in my second derivative. So you could do it here. You could do it either, any of these 3 spots you could evaluate. I just think this one is easier or this one is easier. So if I shove in a negative 10, a negative 10 squared is 100 plus 30 is positive. So he is concave up. Shove in a 1. So 1 minus 3 is negative. He is concave down. And then 100, grab 10. So that makes 100 minus 30 is positive. So he is concave up. And again, I use short little arrows. So that's my visual reminder that I'm talking about concavity. So I'm concave up from negative infinity to 0. And again from 3 to positive infinity. And I am concave down between 0 and 3. Okay. So now we're going to ramp it up for the last one for this section. Actually, that's a good place to stop because I'm going to give you some weird ones next. All right, so that is a good place to stop. And I will see you for the second video.